Hello everyone and welcome back. My name is Mr. Cobalt and today we're going to be talking about work pressure volume or pressure volume work. So we're going to focus a little bit more on work being done by a system. In another video we covered how you could get the heat produced or absorbed using a temperature change. In this video, I'm going to talk about pressure changes and how that can relate to work with regard to change in volume. So we're going to look at how pressure can lead to a volume change, which leads to work. And so in a previous video, I talked about how you can calculate the heat change due to a temperature change. So in that video, we were talking about how Q, which is the quantity of heat, is measured by the mass times the specific heat times temperature change. So if you have a temperature change and you know the specific heat and the mass of the substance that is undergoing the temperature change, then you can figure out heat. In this video, we're going to focus on work. And like I said, we're going to focus on pressure volume work. And what does that mean? Well, if we go back to the definition of work, work is equal to some force applied through a distance. So it's going to be some force multiplied by a distance is going to give you an amount of work being done. Okay, so we also know that if we look at force from the point of view of a gas, right, we can see that a force is going to be equal to a pressure, right? Pressure times, let's see, pressure times an area. Okay, so pressure times an area, and we get that from, if you remember this equation, pressure is equal to force over area, right? So if you multiply both sides, then you get force is equal to pressure over area. And here we're going to be interested in the external pressure. So force is going to be equal to external pressure times the area. And so what we're going to, if we put these together, we have force here. We can substitute force for pressure, external pressure times area. So we get work is equal to pressure, external pressure, times area times distance. And so if we're looking at this from the perspective of a system that has a gas, for example, and the gas is going to expand or contract, therefore it's going to either put work on the external pressure. So you have the external pressure pushing down on the object, whatever it is, and then we have the gas on the inside. The gas is it's either produced by a reaction or it's heated up. We're going to look at it as some sort of reaction. So you have a reaction that goes to completion. One of the products is it's a gas. It produces the gas, and then the gas expands and pushes out on the container, therefore increasing the volume. And so by increasing the volume, it is pushing out against the external pressure. So it's doing work on the external pressure on the container, pushing out, increasing the volume. And so whenever that happens, remember what I said before is when work is done by the system on the surroundings, right? So if you're doing work on the surroundings, you can think of that work leaving you, right? Then you're expending energy. And so you're losing energy in the form of work because I'm doing work on the onto the environment, onto the surroundings. And so I'm losing energy, so that would be negative. And so we need a negative sign for that. So we're going to have to put a negative sign in here to represent that loss of work if we're doing work against an external pressure. The other thing we want to note is in this picture here, we could think of a piston that has some sort of gas in here. So if the reaction is occurring in here, and here's our piston, if you will. So like here's where it was before, right? So the piston was here before, the gas is here, and so the reaction occurs, gas builds up, it pushes the piston up, and so it changes the volume. So first the volume was here, and so then the volume goes to there. So it increases the volume. So this increases in height. So the change in height is from here to here. So the piston moves up, the bottom of the piston moves up from here to here. So this change in height can be considered distance. So we can replace that. So negative external pressure times area times change in height. And area times height, if you're thinking about the area of a circle here, that could be the area of the circle, but if we understand area times height, area is a square unit, height is a length of some sort or distance, and so to multiply those together, you get a change in volume. So then work becomes equal to negative times the external pressure times the change in volume, and we can use that for any change in volume. So as long as we know the change in volume of the container and we know what the external pressure is, then we can figure out what the work is done by the system, right? So if work is done by the system, that's going to lose energy. If it's done by the surroundings onto the system, then that's going to be positive energy. Okay, so this is the equation for pressure volume work. So anytime you have a problem where you have an external pressure and you have a change in volume due to some sort of reaction, then you can use this equation to figure out what the work is done by the system or by the surroundings, depending on how the volume changes. So remember, the change in volume is going to be final minus initial, right? So final minus initial, you have change in volume, final volume minus initial volume. So if I'm increasing in volume, so the final volume is going to be greater than the initial volume. So the change in volume is going to be positive. I put my positive in there, right? So I've gone from small volume to large volume because of the reaction in this piston, for example. And so, so then this whole thing is going to be negative, meaning that work was done by the system, the reaction, onto the surroundings, the piston. Okay. If the volume goes down, right? So if the initial volume was large and the final volume was small comparatively, then the change here will be negative. So I'll have a negative delta V, negative and negative is positive. So then the work will be positive, meaning that work was done onto the system. So through work being done on the system gained energy in the form of work being done on it. Okay. I hope that is clear. I hope that was helpful. In my next video, I'm going to go over a couple of practice problems involving pressure volume work. Thanks for joining me. If you like this video, share this video. Make sure you hit the notification bell for more videos when they come out. Make sure you hit the subscribe button make a comment in the comment section. Let me know what you think, and if there's anything else you want me to cover. Thanks for joining me, and have a good day.